All right. So today we are starting unit 5 of pre-calculus, which is nothing but conic sections. Now, the first thing that we should start with is what exactly is a cone? Who all knows about it? Everybody should, right? I mean, nothing new, nothing different, nothing difficult, correct? If I take this A4 sheet and I roll it up, I mean, in India we use this for a different purpose. I'm not sure if you have traveled in train in India. There are hawkers who come for selling some interesting stuff, and they make paper like this, and then they give you that edible in this one. Okay, maybe you guys would have not seen it, but I've grown up seeing that. So if you look at this, right? I mean, if this becomes a cone. I mean, I'm just giving you one side view of it. It actually is circular in nature, and I was trying to make it like a circle. So if you look at this, this is your cone. I mean, ignore this piece which is uneven, but if you visualize this, it's like, I should have made that for you guys to make it look better. Okay, so this is like, it's very small circle, then bigger circle, and then one after another is kept in such a way that it looks like a pyramid, a circular pyramid, if you can say so, right? That's what is exactly a cone. So in this chapter, when we talk about conic sections, we are essentially going to talk about the shapes that you get by dissecting this cone or cutting this cone. Let's say if I imagine, if you guys visualize that there is a plane which is cutting this across in a horizontal way, then we are talking about cone being cut into a small circle. So this I mean, though it doesn't look like a circle, but if I would have done a better job, this would have looked like a circle. So there was a cone, and we took a plane that just cut it end to end along a plane, and that, if you look at it from the front, it will look like this. So this is a circle which is made by a section of a cone. Am I making sense so far? Yep. Dave, are you able to follow me as well?
Yes, sir.
So if I cut this cone horizontally, then we saw a circle. Imagine if my plane that was trying to cut this is slant. I mean, if instead of cutting it vertically, I cut it in along a diagonal this thing, and then I'm not able to show it to you guys, but if you visualize this, if I cut it like this, then you will see something like a shape like this, because I cut it diagonally. And I mean, again, this is not a perfect shape, but yeah, if I draw a better picture, it will look like an ellipse. Similarly, if you imagine there are two cones, one after another, okay, and then let's look at one cone for now. If I cut it with a plane from here all the way till the end and cut it open, then you will see a shape like this. Yeah? And then if you imagine that I have two cones kept one after another, and then I have a plane which is cutting it from top till the bottom, then you will see something like, so this is one section of the top cone which was like this. So we just cut it from this place. So this one, and then a shape, similar shape at the bottom. So you can visualize this like this. So these are the 4 shapes that we'll talk about, which is nothing but an outcome from the conic section. Meaning, when you cut a cone, with a plane, be it horizontal, be it vertically cutting it open from one end to other, or with a slanted plane, or by cutting only one of the two cones. So you can imagine that you have two cones. Put like this, and then this one is coming by. If you imagine that you have a plane like this, cuts it open, then you will get a shape like this. If you have a plane which cuts this horizontally, then the shape that you will see is the circle. If you are cutting it with a plane, let's say like this, then the portion that it will cut will look like this, which is nothing but this shape. And if you have a plane which is, let's say, is cutting like this, so if you imagine this portion that you will see after this is done, it will look like a parabola open upwards, or if you cut it from here, it will be a parabola facing downward. So this is just a prelude of what we are trying to learn. If you look at it, we are talking about two cones sitting one on the top of another one, and then if you take different planes or cut this cone with different planes horizontally or vertically, or with slanted angle, or cutting both the cones simultaneously, these are the shapes that you will get, be it a parabola, be it a circle, be it a ellipse, or be it this shape which is called hyperbola. So we have talked about circles, we have talked about parabola, but if you visualize that how these shapes came into existence, you will say that this is an outcome by bisecting or dissecting the cones, you get these shapes, and that's why this chapter is named as conic sections. Is that a good jump start, or I'm getting you guys more confused? No response? Okay. Dave, are you clear?
Yes, sir.
Okay. So let me try simplifying this, because now what we are going to learn after this, that will be much more easier and a lot relatable with respect to what we have learned in the past, or you guys would have learned by yourself also. But then knowing the conceptual layout of this would make a lot more sense. So this is your code. Now again, I'm just repeating myself. So I took a horizontal plane that cut this, actually cut this not like this, but it cut like this, and when you look at the top view of that, you will see a circle. So this is one part. If I use a plane which slice this cone from this side, so then this is what you will get to see when you look at the side view of it, and that is nothing but a parabola. If you have two cones on the top, one relaxing on the top of another one, then you will see a shape here, a shape there. So when you have two parabolas as a mirror image of each other, because of your dissecting or slicing the two cones together, you get this shape, which is hyperbola. And then if you use a slanted plane like this, then it will cut this, and this portion when you see from the top, it will look like this, which is called ellipse. So this is circle, ellipse, parabola and hyperbola. These are the four shapes that we'll talk about as far as this unit is concerned. And all this is generated by cutting the cones or pair of cones. That's why this is called conic sections. No doubt so far? Now, let's go back to history a little bit. So, who all remembers what is a circle equation or circle theorem? What do you guys recall? Equation of a circle, if you guys remember. Yep, Dave.
I think it was like x minus h squared plus y minus k squared equals r squared.
Equal to r square. What is r? What is h and k?
R is the radius,
Okay.
and x and y are like, is it like the point on, like a point it goes through, and h and k like determine how, like, I forgot what h and k are, sir.
Okay. So h and k are your coordinates of the origin. Yep. R is your radius. Okay. And x and y anyways, that is describing the whole circle, right? So any point you pick up, the value of x and y coordinate will be your x and y value. Chris, are you able to relate to this one?
Yeah, we learned about this in last year in geometry.
Okay. So this is the standard form of a circle equation. Imagine the same circle. This is a coordinate plane. Imagine the center of the circle is at origin. I did not draw it perfectly, but sometimes you have to believe your teacher. Okay. So let's say this is my origin. Okay, and here this is origin. That means your x and y coordinates are 0 and 0. Yeah. So in that case, if you substitute this value in this equation, which is a standard form of a circle equation, your x and k will be 0 because h and k is nothing but your x and y coordinate. So you will put x minus 0 squared plus y minus k squared, y minus 0 squared equal to r squared, or you will say x squared plus y squared equal to r squared. Yeah. So this is the same standard form of a circle equation. If your origin is if the center of the circle is at the origin of the coordinate plane, then your same circle equation becomes like this. Yeah. Now let me give you guys another flavor of it. I wish I had a toy which I could use for demonstrating what I'm trying to say, but let's not worry about it. Before we go deeper into it, okay, now let's visualize this circle and then let's visualize this ellipse. Okay. Now think about it. See, there's certainly some relationship between these two. Okay. It doesn't look. See, if I ask you to visualize this and this together, you'll probably end up laughing at me, saying, "Sir, either you need to get your eyes checked, or you're probably too tired." But if I say this and this look somewhat closer to each other, you might tend to believe. Yeah? Yes or no? Yeah? Now, why I'm saying so is because, see, if you look at squeezing this from here, what will happen? I mean, imagine a boiled egg which you can squeeze or unsqueeze, right? So imagine this is the boiled egg. If you squeeze it from this side and try making it look like a circle, it might happen. I mean, okay, if it's not boiled egg, something more squishy, right? If you squeeze it from the corner, it might look like a circle. Get closer to this. Or if this is a squeezy thing, if you squeeze it from here, it will expand in this direction, and it will give you a shape like this, right? So we can certainly debate whether ellipse is the one which can give birth to a shape like this, or circle can be squeezed to give you ellipse. That we can always debate. But just because we know, we have learned about the circle equation much before, so we will probably take that as our base. So, and we'll use that as a base to look at now how do we relate things. Is that okay so far? I mean, I know I cannot force you guys to believe that ellipse and circle are not far from each other, but we'll still go with the assumption for now. Okay. Now, in case of a circle, you know that, okay, if let's say if it's going to origin or whatever be the case, the only thing that you need to know is this radius remains fixed, meaning any point on the center to the border of the circle or the perimeter, every distance is the same, which is called radius. But if you try relating that with the ellipse here, you would certainly not agree to me, even if I forced you to believe that these two are somewhat similar. But no matter how much force I apply here, you would not agree. You don't really see a situation here where there is a point somewhere on this ellipse that is equidistant from all the all the places on the border of this shape. You will certainly not agree, and I would not want you to agree either. Even if you are thinking of agreeing, I would say don't agree. So there is a difference. So now let's look at the next part of it. So what I've done is, now let's assume for now that this is my origin, okay, which I will say is the center of this ellipse. Now why I'm saying so, because this point is making or creating some symmetry with this shape. What do I mean by that? There is a horizontal line which divides this shape into two equal parts. Similarly, there is a vertical line which is crossing this point, which is again split into two parts vertically. Yeah. So this horizontal line and this vertical line, it intersects at this point, where this horizontal line is splitting into two equal parts, and the vertical line is also splitting into two equal parts. And this I will say as the center of the ellipse. Okay. How do you pronounce it? Ellipse? Ellipse? How do you say it? Because I have Indian accent. You guys speak English better than I do. What do you call it? Ellipse or ellipse? One of you have to teach me.
I just say ellipse.
Ellipse. Okay. Yeah. Fine. And again, I'll have to learn English from you guys, okay? I never went to English schools. Okay. Alright. Coming back to this one. So, if you look at this ellipse, this is my horizontal axis and this is my vertical axis, which is splitting this into two equal parts, and where this point meets, that I will call as center. Now, from a terminology point of view, here we call it radius, here we call this, now if you look at this, right, this portion is broader or bigger. I mean, if you look at just this shape, this is short and wide, correct? So this one from here to here or here to here, this one is called the major axis. Okay, this one is called major axis because this is where your length is more, and this is called minor axis. If I flip this and make it like this, then this will become your major axis and this will be your minor axis. Is that part okay? So accordingly, this is called major axis or major, you can call this as major radius. Okay. So it's given a name here to the end is called semi-major radius, and this one from here to here, it's called semi-minor radius. So this is your major axis, this is your minor axis, and from here to here, this is called semi-minor radius, and this is called semi-major radius. More from a terminology point of view, because you will come across these points, and then if you know what is called what, then you will be able to relate. Yeah. Are you getting with me? Okay.
Yes, sir.
Now we are doing side by side comparison of a circle and an ellipse, right? So here we have only one radius. Wonderful, no problem. Here we have two. You can call it radius, or you can call it. There are two. They call it radii. Or I don't know how to pronounce it, but yeah, it's called. These are the major radius and the minor radius. They are together called. These are the radii of the ellipse. So here, in this case, you have only one radius. Here you have two. So how you convert this equation, or how do you find an analogous part of this equation, comparing that with the circle is, see, now look at this one. Let me create some real estate. So here in the case of a circle, it was, let's assume that this is meeting at point 0, okay? This is origin. Here also let's say it's the origin. So that we have to write less. So it will become x minus h is 0, k also 0. So x square plus y square equal to r square. Here also let's assume that this is radius. And I'm just keeping it same way, okay? X square plus r square, y square equal to r square. I'm just keeping it r. There is nothing called r in this place, okay? But this will become x square plus r square plus y square plus r square equal to 1. This is my equivalent equation, circle equation, when my center is at the origin of the coordinate plane. And we are trying to find out the equivalent of this one. So what it has come down to is that yes, here you don't have one r. So instead of saying dividing this by r, along, if this is your x-axis, what is your this is your major radius, semi-major radius. So that, let's say that is a. So you'll not say r square. This will be x square by a square plus y square by, let's say this is b. So y square by b square equal to 1. So what did we do is, if you just do side by side comparison, right? Here you had one radius, here you did not have one radius. So here you had, let's just say we had two radius, a and b. One semi-major radius and or let's call it major radius and minor radius. Okay? It's semi-major axis and this is semi-minor axis. We'll just call it major radius and minor radius for the sake of simplicity. So here, instead of having one radius, here you have two radius, the major one and the minor one. So whatever you have along the x-axis, be it major or minor, that radius divides. Instead of dividing by r square, you are dividing by that radius. Whatever is along the y-axis, you are dividing it by that radius. So that is how this becomes your equation for the ellipse. Am I getting you guys confused, or am I still making sense? So if you do side by side comparison, this is exactly what it is. Your circle equation will get you x square plus y square equal to r square. The equivalent of that will be x square is, so here you are dividing everything by r square to get a 1 on the left hand side, on the right hand side. Here you are not dividing by r square because there is nothing called r. You have two radius. So x, whatever is the radius along the x axis, square of that, and whatever is your radius along y-axis, square of that, because it's a symmetric shape. Obviously, we will need differentiation and integration concepts to prove this formula, which we'll do when we learn calculus. But for now, from understanding point of view or from correlation point of view, this will be your equation that we look at, and we are just trying to do a comparison here, right? So in my classes I have proved all the formulas except for circles, because circle needs a different approach, and that is where we need to be a little more well versed with calculus before we can try proving that. Since we have not learned calculus right now, I'm not going there. So that's why I'm kind of, even if I'm myself not convinced, I'm kind of forcing you guys to believe that this is the formula. Yeah. So now, if you relate this with, now this left side is your circle, right side is your ellipse. Now if you extend that and go back to a standard form of the circle, your equation will be x minus h square by r square plus y minus k square by r square equal to 1. This is your standard form of the circle equation. If you compare that with your ellipse, it will be the same thing. Let's say your origin is h and k, so x minus h square by a square plus y minus k square divided by b square will be equal to 1. So here h and k are the coordinates, x and y coordinates respectively of the origin of the ellipse. So this is how we will relate this. Are you guys with me so far? Is that making sense or it's not? Dave?
It makes sense, sir.
Okay. So now let's look at a few problems to deal with. So let's say if somebody says that the kind of problem that you will deal with, right? I mean, obviously, when you go to Conic Academy and try doing the unit test, you will see more examples. If somebody says x minus 8 square by 25 plus y minus 10 square divided by 64 equal to 1. Find out the coordinates of the center, and also find out the major and minor radius of this ellipse, right? So again, this is your a square, this is your b square. Just by looking at this, which one is your major radius, if you guys can tell me? Just by looking at this equation, I mean, obviously I'm making you guys believe that this is an equation of an ellipse, and if you just look at this equation, what will be the value of the major radius, or which one is the major radius? Is it a horizontal ellipse? Is it a vertical ellipse? What is your interpretation by just by looking at this?
Is it a vertical ellipse?
I would want to hear it with a little more confidence. Be it right or wrong, it's okay. You said vertical, I'm sure you would have thought about it, correct?
No, because wasn't it like A is the major eclipse and B is the minor eclipse? So
So A is not the major radius or B is not the minor radius. A is your radius along the x-axis, B is the radius along the y-axis. That is how we should interpret that, right?
So in this situation, then 64 would be B, meaning that it's the major radius.
It is the major radius. So basically, your ellipse is standing right now. Okay? Yeah?
Yeah.
So basically, this is 8 square. So your major radius is 8, and this is 5 square. So your minor radius is 5. Now, just by looking at this, just by, see, the kind of problems you'll deal with relating to this concept, right? It will be always, you have to look at whatever is your value here of the radius, whatever is coming here, that is along the x-axis, meaning the horizontal axis. So whether it's a slim trim eclipse like this or short and fat eclipse like this, that will be determined by whether your horizontal radius, the radius along the x-axis is more or radius along the y-axis is more, right? This is a term that I have learned from my kids. One of my younger daughter, one day she came from school and said that there is a child who is vertically challenged, and that was a new term for me. I was wondering what exactly does it mean. Then I realized that when somebody says vertically challenged, there is a problem with the vertical height of the child. That means short. So this is your vertically challenged eclipse, and this is your horizontal challenged eclipse. Yeah, and yes, Dave.
Wait, so just for understanding, so if the number is below the x and it's greater than the number below the y, then the x stretch is greater than the y, right?
Right. So you look at it this way. Always relate this with a simpler form of this equation. Your equation says this: x squared by a squared plus y squared by b squared equal to 1. Here the assumption is the origin is the center of the eclipse is at the origin. So you don't have h and k value, both are 0. So if you relate it this way, whatever is under a is a value along the x-axis. Whatever is b or below y squared, that is your value along the y-axis. Yeah. Okay. So you will see which one is more. If this one is more, meaning it's tall and slim one. If this one is more, meaning your ellipse is expanding along the x-axis, or is expanded along the x-axis. So this is where. So basically, if x term is more, it's horizontal. If y term is more, it's vertical. So it's like somebody like me, right, who is not very tall. I'm A. If somebody who is very tall, that person is B. Yeah. And so thankfully, I don't look like ellipse so far, but gradually I might end up, right? When I put on some more weight, I will look like, when I become fat, meaning my A will keep on increasing. Yeah. So that's a lame way to relate, but yeah, if that helps you remember, no harm in doing so. Yeah. But yeah, no disrespect for the width or the height of it. It is natural thing. It's just a mathematical representation. We're just trying to relate that, okay, if my A value is more, meaning my length along the x-axis is more, it's an ellipse that is lying on the floor. If my B value is more, that means my vertical orientation is more, that means it's a standing ellipse. Yeah. So that will be one way to relate. Now let's learn about, let's look at some more things. I'm just trying to recall what all did I tell. Okay. So we talked about what is conic section, introduction part of it. That is where we talked about what is a circle, what is an ellipse, what is parabola, what is hyperbola, and obviously we'll learn about all those. We started with circle equation, circle theorem we have learned enough, so that's why we're not going to that. We started with ellipse, where we found the standard form of the equation for ellipse, and by looking at the equation, how do we determine what is the major and minor radius of the ellipse, and then how that helps us find out the center of the ellipse or the radius of the ellipse. Yeah. Now let's see the interesting problem that you will deal with, right? See, there's nothing cryptic about this concept. It's all about how do we relate it at runtime and how do we use the concepts. Let's say, if I say I have an ellipse like x minus 3 square by 9 plus y plus 3 or y plus 2 square by 16 equal to 1. Okay. So, if I move this ellipse by 5 points, by 5 units, okay, to the right, what will be the coordinate of my origin? Okay. So I'm just writing it down. Okay? Move to right by 5 units or 5 places, whatever you call it. Okay. What will be my coordinates? For center and the extreme end point to the right on major axis. Extreme end point to the right on, let's say, minor axis. Okay. Because I realized what I have done here. Okay. So now look at this question. Okay. This is an interesting word problem. Nothing complicated about it, but it's all about how do we visualize and how do we relate it with the concept that we have learned. The question is, this is your equation for this is the equation that we have been given for a conic section. Nobody is telling you whether it's an ellipse or parabola, hyperbola or circle. But we have to make our judgment and figure out what kind of shape this is talking about. And then it says, if you move to the right by 5 points, so this shape is somewhere in the coordinate plane. If you have to just shift it to the right by 5 points, what will be the coordinates for the center and what will be the coordinates for the extreme end point to the right of the minor axis? Too much of information, right? It might get you guys confused, but again, reading it from the beginning, and this is my what you call recommendation to all of you, that whenever you have a question, read it few times. Okay, that makes the question look easier. So I'm just reading it one more time. I know I might be wasting time for you guys, but it's all about building that habit. So this is the equation. We don't know whether it's a circle or parabola or ellipse or hyperbola, but we just have the equation. It says move this to the right by 5 units. So this shape, you draw it and you move it to right by 5 units, and then find out the coordinates for the center after moving it by 5 units. And again, I know I have not clearly written it, but I'm just reading it for you guys. So this shape, we have to move to the right by 5 units and then find out the coordinates for the center and the coordinates for the extreme end point to the right on the minor axis. So a lot of information here, but the first thing you have to do is, okay, anybody wants to give me any idea with respect to how you want to approach this one? Just the approach. Solution we'll find out together, that's okay. You understood the problem, right? We have an equation, it's going to draw something, and then we have to draw it in coordinate plane and figure out if I move it to the right by 5 units or 5 places or 5 unit places, what will be the coordinate of the center of the shape, and then what will be the coordinate of the extreme right end point on the minor axis.
Wouldn't you just have to add 5 to everything, maybe? To the midpoint, you would add 5, such as it'd be from instead of -3, 3, it would become 2, 3.
Right. So I think we are thinking in the right direction. I will do that in an even simpler way. First thing is, when I look at this equation, something by square of something, something squared by square of something. So this, and when I look at the denominator, they are different. So first clue that I get by reading the question is, it's certainly looking like an equation for the ellipse, not ellipse. And then another clue I get here is minor x. People talk about minor axis, major axis. So this affirms that this is certainly an ellipse that we are talking about. So let's look at it. Now by looking at this one, x minus x squared plus y minus k squared. This is not minus, it's plus. That means here my center is h and k. Here h is 5, 3. K is y minus k. Here is plus 2. That means it is minus 2. That is how it would become plus 2, correct? So I got the coordinates for the center. Yeah? Are you with me so far? Just by looking at the equation, my standard form is x minus h squared by a squared plus y minus k squared by b squared equal to 1. So here I have a plus, that means this k has a negative value, that's how it's becoming plus. Yeah? Okay, so now we got the center. Now what is my minor and major radius here? My minor radius is 3. So this is 3 squared. I'm just writing a 3 squared here. And this is 4 squared. So this is my major radius. That means this is vertically oriented ellipse. It is somewhat like this. Yeah? So apparently this is my minor axis or minor radius. This is my major axis or major radius. Yeah? So here to here is my minor radius and here to here is my major radius. Now this is 4 and this is 3. Now relate that with a, so the mistake I committed is I should have put the coordinate plane first. And what is my center? 3 and minus 2. So 3 and minus 2 somewhere here. This is my center. And this is a vertically oriented one. So minus 2, it will go till 2, something like this. So this is my center, which is 3, minus 2. Okay? So this here to here it is 4. 4, this is my major radius, and here to here it is 3. Why I am saying 3? Because this is my minor radius. Now how does it help? See, what are the extreme points? When you look at an ellipse, right? What are the extreme points? This and this are the extreme points of your, or along the horizontal axis or the minor radius, minor axis here. And this one and this one are your extreme points along the major radius. So look at the second part of this one. Coordinates for the center, which we have already found. Now we are saying is move to right by 5 units. So we have to move it to the right by 5 units, meaning we are just shifting this guy by 5 units. What will change? My y coordinate will not change. Only thing will change is my x coordinate, which was 3 minus 2 before, and I am moving it by 5 units to the right. So 3 became 3 plus 5, as you were saying, Chris. Yeah? So this became 3 plus 5 or 8 minus 2. So this is my new coordinates of the center. Yeah?
Yeah.
Now, tell me what is the coordinate of the extreme end of the minor axis on the right hand side? What is the coordinate for this point, the extreme end of the minor axis? So this distance is how much? 3, right? This is my minor radius, correct?
Yeah.
So 3 minus 2, so this will be 3 places more. So 3 plus 3, that will be 6. 6 minus 2. Yeah? Because your y value is not changing, it's only x axis, because we are looking at it along the horizontal axis. Correct? So this is 6 comma minus 2. Now this whole thing is moving. So this moves from 3 to 8. This 6 will move from 6 to by 5, right? This is moving by 5 units. So whole thing shifts by 5 units. So this point, which was 6 and minus 2, this becomes 6 plus 5 comma minus 2. So this is your coordinate. This is the revised coordinate of your extreme end point on the right hand side for the minor axis. So if you look at this whole thing, right, am I teaching you guys something complicated? Probably not. It's just about how you will visualize this. And Chris, you started on the right note. You said, okay, fine, I will probably add. What I'm saying is, whatever you want to add, you can add. Only thing I'm adding on the top of what you're saying is, draw it on a coordinate plane, visualize it, you will get all the clues. See, here in this whole question, we have to just look at this equation to find out the coordinates of the center. Then we're talking about moving this by 5 units to the right. So you have to imagine this as something that is moving by 5 units together. This point, whatever is the coordinate, that moves by 5 point. This point, whatever is the coordinate, that moves by 5 point. This point, whatever is the coordinate, moves by 5 point. So you find out the coordinate of these place points and then you relate it. Yeah? So for every problem, 2 tricks that you guys would want to practice for yourself. One is read the question a couple of times. Trust me, the intensity or the complexity of the problem comes down by at least 20-30%, if not more. Okay, if you read it 2 times. Again, I'm talking about the reading the questions multiple times only for the ones which are looking more verbose or looking more complicated. Okay, where you have a doubt in your mind. If somebody is talking about multiply 15 by 5, it's all about knowing the tables and saying 75. So you would certainly not have to read it 5 times to waste your time. You would want to spend your time, or you would want to save your time for the ones which needs little more focused view of, which needs more focused attention. Why I'm using focused and attention together? Okay, it needs more focus. Simple. Read it a couple of times, and then try doing the scratch work. Do some. Don't hesitate to draw things. Okay, even if it looks dirty and messy, that's fine. That gives you a more pictorial view of what the solution would be. What happens is we keep grappling with the problem and think that it's difficult. As soon as you read the question a couple of times and you have a fair idea of what exactly has been asked, start drawing. Start putting it on a piece of paper. And then you'll see your brain comes along with you. It gives you a guidance actually. Right? I mean, this is just an example. This is not a complicated one, but still I'm saying. Yeah? I know that was an overdose of information, but yeah, sometimes I have to keep on pushing you guys towards certain behavioral changes while doing maths. Okay? Alright? Now, let's learn one more concept. Are you guys clear so far? So whatever we have learned so far, this is good amount of concept that you would need for doing your practice on Khan Academy. Okay, if you try going through Khan Academy by yourself, you'll see that same concept has been repeated over and over again. But the crux of that is there are 2 things. How do you come up with a standard form of an equation for ellipse, and then how do you relate that with your understanding of circle so that it helps you derive what you need to derive, and then apply your magic trick for solving the problems and see if it is helpful. Now there's one more concept that you would want to learn, or rather I would say this is a property of an ellipse. So there's something, there's an interesting word, okay, that you might have heard. It's called foci. Foci of an ellipse. Have you come across this term before? Dave or Chris?
Oh, I haven't heard it, sir.
Say that again.
I don't think I've heard it before, sir.
Okay, cool. So that makes me feel happier that at least I'm able to teach you something. How about you, Chris? Have you heard about this term before?
I've heard about it, but I never really learned it.
Okay, so this is like I say, right? If you talk about triangle, you're talking about a shape, a closed shape which has 3 sides and 3 angles, and sum of all the angles is 180 degree. This is a property. Same way, ellipse also has a very unique property, which says if you are looking at an ellipse, okay, if you look at it along the major axis, okay, there are 2 points, there are 2 symmetric points along the major axis on the ellipse, or there are 2 symmetric points on the major axis of the ellipse, which is a very unique property. You pick up any point. So now let's first look at, if you look at this major axis, here to here, let's say this is along the x-axis, so this is A and this is also A, right? Here to here it is B, and this portion is also B, right? This is a major axis, a major radius, and this is a minor radius. Yeah. Now, what this property says that these are 2 points, symmetric points. Symmetric as in this is distance from here to here is same as distance from here to here. Likewise, distance from here to the origin or the center would be same as this distance also. So this is symmetric point. It's not that one point is here and another point is here. Okay. So these are 2 symmetric points along the major axis, and the uniqueness of these 2 points is that if you pick up any point and join these 2 points. So let's say this is D1 and this is D2. Okay. You just picked up one point on the perimeter of this, on the boundary of this ellipse. This D1 plus D2 will be equal to 2 times the major radius. Okay. So you pick up this point, this distance from this one foci to this point, and distance from other foci to this point. If this is D1, D2, sum of that is 2a. Now you pick up another point. Let's say this is D3, D4. So D3 plus D4 is also equal to 2a. So that's a unique property of ellipse, which says that foci are 2 points, are 2 symmetric points along the major axis of the ellipse, where any point on the boundary of the ellipse, sum of the distance of that point with both the foci is equal to 2a. Now we can just look at a simple proof of that. Okay. See, look at this. Here to here, this is symmetric, right? So this point to this point is same. Let's say this is H. So this will also be H. Yeah. Similarly, here to here. Let me use a different color pen so that I don't create confusion for you guys. So let's say the blue one, let's say it's K. Origin to this point is K, through the first foci, and then again origin to second foci is also k because this is symmetric. So equidistance from here to here. So my h is from here to here. This h is here to here. Now, if I pick one point, this is also a valid point. Yeah. So here, as per this rule, any point on the boundary of this will be the sum of this distance plus this distance will be equal to 2a. Let's see if that is the case. This is h. So first foci to this point is h, and second foci to this point is also, this is k plus h. K plus h. Now, so this k plus h, that is distance from second foci, and this h is the distance from the first foci, which is equal to 2 times h plus k. Now look at this. What is h plus k? H plus k is nothing but a. So this is 2 times h plus k is a. So that is h times psi. So we picked up one point on the extreme end and found that this is equal to this length is equal to 2a, because again these foci are symmetric, meaning the distance from this end to here is same as distance from here to here. Same way it is equidistant from the origin or center also. So we saw that we just picked up a point on the extreme and then we used that information to figure out if that is the case. Are you guys with me? What do you? Yeah, Dave.
So I just have a clarifying question. So in like the most basic term is foci, just like where like one side reflects over the center to form a equal image. Like
Foci always comes in a pair.
okay.
So if you have an ellipse, you're talking about foci as a pair of points. Every ellipse has a pair of foci. Let's say these two are the foci. The unique behavior of the foci or the property of the foci is this is symmetric, meaning this will be same distance from this end, which is the distance between this foci and the other end. Or even if you compare the distance between the center, these two will be matching.
Okay, I just have one more question, sir. What if the foci was like on the circle, so it like didn't have a h value? Is that possible?
No, foci is always along the major axis.
So does it like if it's on like this edge of the circle, like at the end of the line,
Here?
would that not be the major axis? Yeah, right there.
Yeah, so then if one of the foci is at this end, other one will be at this end.
Okay, thank you,
So
sir.
then that is also, see if you look at, if you pick up, let's say both the foci are on the two extreme ends, and you pick up this point. See, this point to this point distance is 0, but from here to here is 2a, right? So again same thing, distance 1 of the foci plus distance 2 from the foci is adding up to 2a. Yeah?
Oh, okay, I see it now, sir.
Yeah. Now, we can derive a formula out of it. We have almost hit the time. So let's pick up this one quickly. Okay. So now let's say these two are my foci. Okay. And this is my A, this is my B. This is my A, this is my B. Now let's say I pick up a point here. Okay, let me prove this formula next class. Right now, I will leave you guys with the basic understanding of foci and what exactly it means, and we realize that foci are 2 points along the major axis, where if you pick up any point along the boundary of this ellipse, the distance from one foci to that point plus distance from other foci to that point will always add up to 2a. And remember this, your foci will never be along the vertical axis or any other place on the ellipse apart from being on the major axis. Yeah? So that brings us to the end of the class. We'll talk about the next formula for foci and then the remaining concepts around hyperbola and parabola and other concepts that we need to learn as part of this unit. Any questions before I let you guys go? Chris, Dave?
No, nothing for me. Nothing.
Tell me one thing, if I was successful in getting you guys confused.
No.
No? I could not succeed today. Better luck next time. Alright, see
I
you
was
guys.
a little lost at the end, but like at the beginning, but I got it towards the end.
Okay, yeah, so that happens, okay? I mean, we are all normal people, right? What happens is we learn something in one go, sometimes we take 2 attempts, sometimes we take 3 attempts also. And that is perfectly fine because, I mean, taking attempts is not a problem. Not taking attempts is a problem. I mean, if you find something complicated and then you don't try to learn it, that is where we go wrong. But as long as you're trying, trust me, there is nothing that is not something that we can understand. Yeah? That we can't understand. That's what I wanted to say. Okay? Alright. Too much of gyan for today. I'll let you guys go. Enjoy the rest of the evening. Have a good night, good dinner, and take some rest. Yep?
Thank you, sir.
Alright.
Thank you, sir.
Thank you. Bye bye. Good night.